The James Webb Space Telescope's stunning revelation, 14 never-before-seen images from outer space. The James Webb Space Telescope has once again pierced the veil of the cosmos, revealing 14 images that challenge our understanding and ignite our curiosity. These tantalizing glimpses into the universe's distant reaches invite questions and beckon exploration. From enigmatic celestial formations to the intricate dance of distant galaxies, each image is a testament to the uncharted territories that await us. What hidden secrets do these 14 snapshots hold? Join us on a journey through the stars where the unknown beckons and every discovery brings us closer to answering the eternal questions of our existence. Prepare to embark on a visual odyssey that will reshape your perception of the cosmos. Image 1. HA 4647, the dynamic dance of star formation. Brace yourself for an interstellar spectacle as we witness two stars caught in the act of creation, sending out jets in all directions. In the depths of the Vela constellation, just 1470 light-years from Earth, lies a mysterious complex known as Herbicaro 4647, or HA 4647. What's happening there might remind you of the boundless energy in kittens playfully scampering around, but in this case, it's astronomical. HA 4647 isn't just a single star, it's a pair of stars gathering mass and taking shape. Like young children growing into adults, these stars are wild and lively. Imagine a fountain turned on and off repeatedly, with water streaming, colliding, and forming unique patterns. This water dance in a rush is a simplistic way to envision the jets emerging from the stars, constantly moving and reshaping. NASA's James Webb Space Telescope, equipped with the power to see in high-resolution near-infrared light, has given us the most detailed portrait of these stars. Near-infrared light is a light that our eyes can't see, but is perfect for peering through dust and gas in space. Until Webb, many telescopes had studied Herbicaro 4647, but none could capture the details we now see. Picture this: an intricate textured canvas filled with fiery orange lobes, wavy blue lines, and a blue cloud that looks effervescent. These vibrant colors and forms don't just make a beautiful image, they tell the story of the star's growth and behavior. Within the orange-white splotch at the center, the two stars are deeply embedded in a disk of gas and dust, feeding their growth, almost like how plants are nourished by soil. From the central hub, two-sided loads burst forth, fiery orange in color. Now think of a car's exhaust pipe, like the smoke being ejected from the vehicle. These stars spit gas and dust. Over thousands of years, they have shaped these loads into what you see today. Have you ever noticed how waves make different patterns when they crash into rocks? Similarly, the star's more recent ejections create wavy patterns as they meet older material. They might even end in uneven circles or curl into beautiful lines. But why is this happening? Why do some jets move faster while others carry more material? The answer is how much matter fell onto the stars at specific times. Imagine feeding a hungry child different amounts of food. The reaction will vary. Take note of the blue cloud, also known as a Bok globule. This dense region of dust and gas might appear unimportant, but it plays a significant role in shaping the jets. In simple terms, it's like the canvas the painter, the stars, uses to create a masterpiece. When viewed in regular visible light, it looks almost entirely black, but with Webb's unique sight, we can see through this cloud, revealing not only more of HA 4647, but also a deep array of stars and galaxies behind it. Now glance towards the upper right and lower left of the image. Notice the different shapes and directions of the material. Varying patterns hint at cosmic wind's influence and previous ejections. And though we're viewing HA 4647 straight on, it's slightly angled. Oddly, the smaller right half is closer to Earth, even though the left side seems more prominent. Isn't space full of surprises? In a few million years, these lively ejections will subside, and the binary stars of HA 4647 will take center stage against the galaxy-filled backdrop. The scene spread across 3.1 light-years or 7.3 Arc-minutes will transition from a chaotic ballet to a calm, mature existence. Thanks to the closeness of HA 4647 and Webb's advanced imaging, we've been able to dive into this rich, fascinating world, witnessing the dynamics of star formation, the influence of surrounding material, and a glimpse into the life of young stars. So, what does the future hold for HA 4647? Will we discover new details about star formation? Only time technology, and our relentless curiosity will unravel these celestial secrets. Isn't it amazing that the vast universe is constantly in motion and changing? Yet here we are, able to glimpse it and understand more about where we come from. Looking at HA 4647, we've seen stars being born and witnessed the processes shaping the cosmos. Image 2, El Gordo, navigating the heftiest galaxy cluster. Allow me to guide you on an astronomical journey far into the vastness of the universe towards a captivating destination known as El Gordo, officially labeled SECLJ01024915 or SPT-CLJ01024915. El Gordo isn't a single star or galaxy, but a colossal cluster of galaxies located in the Phoenix constellation. Even more astonishing is that this enormous entity is 7.6 billion light-years away from us, spanning an impressive 6 million light-years across, or about 2.3 arc-minutes in image dimensions. Let's start by getting our bearings right. Look at the image of El Gordo, and you'll notice compass arrows showing the north and east directions. However, there's something unique in space navigation. Unlike the maps we use on Earth, where we view the compass from above, we consider it from below in space. The relationship between north and east is flipped, which can be confusing. Imagine lying on your back, looking up at the sky, and it might start to make sense. Let's delve into the fascinating colors you see in the image. Believe it or not, you're witnessing not visible light, but near-infrared wavelengths of light. How can we see it then? Through the magic of technology, these invisible wavelengths have been translated into colors our eyes can perceive. Picture a box of crayons. Each crayon has a specific color. When you draw, that color appears on paper. Similarly, the near-infrared light has been drawn using visible light colors. The color key in the image tells you which near-infrared filters were used, with the color of each filter name matching the visible light color representing the infrared light. Why is it called El Gordo, which translates to the fat one in Spanish? Simply put, it's massive. El Gordo is one of the most significant galaxy clusters ever discovered. Imagine a crowded city with billions of people. Now think of a cluster where each person is an entire galaxy. That's the scale we're talking about here. Within this galaxy cluster, there's an intense gravitational pull holding everything together. Galaxies, gas, and dark matter interact, collide, and merge in a cosmic dance. Dark matter is an invisible substance that makes up a significant part of our universe. Imagine it as the invisible glue holding everything together. What secrets does El Gordo have? What can it teach us about the universe's history and structure? By studying such a massive galaxy cluster, scientists can learn about dark matter, the expansion of the universe, and how galaxies evolve and interact. The distance of El Gordo also allows us to look back in time. Light takes time, so the light we see from El Gordo has traveled for 7.6 billion years to reach us. In a way, we're looking at a snapshot of the universe as it was billions of years ago. El Gordo is a rich and complex cosmic treasure, far more than a simple collection of galaxies. Its name, colors, and structure tell a tale of cosmic forces at play, of time and distance on a scale almost beyond our comprehension. It's a bridge between the visible and the invisible, between what we know and what we're yet to discover. Could there be more clusters like El Gordo waiting to be discovered? What could they reveal about our place in the cosmos? These questions remain open, fueling our curiosity and driving us to explore further. After all, in the grand tapestry of the universe, every thread, every cluster like El Gordo, contributes to the whole picture. Understanding one helps us unravel the other. Image 3. PBS 70 Inner Disk, a nursery for planets. Let's embark on an exciting journey to a distant corner of the universe, deep within the Centaurus constellation. We're heading to PBS 70, a young star with a swirling disk of dust and gas, commonly referred to as a protoplanetary disk. What makes this particular disk so unique? It could be where new rocky terrestrial planets are forming. A nursery, not for babies, but for planets. PBS 70's inner protoplanetary disk isn't just any cosmic phenomena. It's a significant discovery recently explored by NASA's James Webb Space Telescope. Within the confines of this disk, scientists have detected something extraordinary. Water vapor at distances of less than 100 million miles from the star. That may sound like a long way off, but it's close in astronomical terms. Why is this discovery so fascinating? It's the first time water has been detected in a region where rocky terrestrial planets, like Earth, could be forming. Imagine a potter's wheel spinning and shaping clay. Similarly, the elements in this protoplanetary disk, including water, are spinning and shaping new worlds. One of these forming worlds, a protoplanet, is even depicted at the upper right of the concept. Water is essential for life as we know it, so water vapor in the PBS-70 system raises intriguing questions. Could this water someday become part of a new planet? Could that world support life? While we don't have the answers yet, the very possibility opens up an exciting avenue of exploration. The evidence of water was found using Webb's MIRI, mid-infrared instrument. This instrument captured a spectrum of the protoplanetary disk, showing emission lines from water vapor. Think of a spectrum as a barcode that reveals what's inside a product. In this case, the range showed the barcode of water in the inner disk. We've always been fascinated by how things come to be, and planets are no exception. PBS-70's inner disk is like a construction site, and the ingredients, including water, are all there, ready to build new worlds. But how does it work? Dust and gas particles within the disk stick together, gradually forming larger and larger clumps. Think of a snowball rolling down a hill, growing as it picks up more snow. Over time, these clumps can grow into protoplanets, and eventually, they may become fully fledged planets. The discovery of water in the PBS-70 system is more than just an interesting fact. It's a window into the birth of planets and a hint at the incredible diversity of the universe. Could other systems like PBS-70 exist with their unique blend of elements? What else might we uncover in this cosmic nursery? As our technology advances, the PBS-70 inner disk is a living laboratory showcasing the early stages of planetary formation. It's a vivid reminder that the universe is a place of constant change and creativity. As we continue to explore and understand systems like PBS-70, we learn about the mechanics of the cosmos and expand our horizons, venturing into uncharted territories and asking questions that might one day change how we view our place in the universe. So, the next time you look up at the night sky, ponder the wonders it may hold. Remember that every star could be a sun to a distant world, and every protoplanetary disk could be the birthplace of a new planet. What other mysteries and marvels might we uncover as we continue to explore the vast and complex universe around us? Image 4. Rediscovered, renamed, reclassified, the intriguing journey of NGC 6380. In the constellation Scorpius, or the Scorpion, resides a somewhat mysterious and intriguing globular cluster named NGC 6380. This cosmic collection of stars lies 35,000 light-years away from Earth and holds a unique place in the history of astronomy. But what makes NGC 6380 so unique? Let's unravel the story of this cluster and explore its path from discovery to rediscovery, naming to renaming, and classification to reclassification. Gazing at the image of NGC 6380, one can't help but notice a very bright star, HD 159,073, at the top. This star is a much closer neighbor to Earth, at only 4,000 light-years away, compared to the distant NGC 6380. While this neighboring star shines brightly, the real story is the globular cluster itself and its peculiar discovery and naming journey. The NGC 6380 cluster was first discovered by James Dunlop in 1826. Perhaps reflecting pride, he named it Dun 538. Do names tell us something about the people behind discoveries? If so, what does this tell us about Dunlop? 8 years later, in 1834, John Herschel stumbled upon the same cluster, and unaware of Dunlop's discovery, he also took the opportunity to name it after himself as H3688. Interestingly, the story continues. The cluster was rediscovered in Paris by Pismis in 1959, who cataloged it as Tom 1 and even referred to it as Pismis 25. The names change, but the cluster remained the same. So why did it get rediscovered so many times? Did the technology of the time contribute to this confusion, or was it something more? The globular cluster NGC 6380 wasn't just known for its name changes. It also had a shift in its classification. For a long time, up until the 1950s, NGC 6380 was thought to be an open cluster. An available set is a group of up to a few thousand stars formed from the same giant molecular cloud. Think of it as a large family of stars born together and drifting through space together. Today, NGC 6380 is widely recognized in available catalogs as a globular cluster. The NGC stands for the New General Catalog, a system that originated in 1888 and categorizes collections like this one. NGC 6380 may seem like an unfamiliar name, but it represents a standardization that helps astronomers worldwide communicate more easily. The tale of NGC 6380 is more than just a story of a distant collection of stars. It's a narrative about human curiosity, the evolution of science, and the passion of astronomers who look to the sky, making their unique mark on this cluster through rediscoveries, renamings, and reclassifications. The story of NGC 6380 challenges us to think about how we perceive the universe and how our understanding of it evolves. How many more mysteries like NGC 6380 await us? How did the technology and collaboration of today contrast with the times when this cluster was repeatedly rediscovered? What lessons can we learn from the history of this cluster that might guide our future explorations as we continue to explore the vast reaches of space? The legacy of NGC 6380 reminds us that the universe is not just a place of constant discovery, but also a canvas upon which we sketch our ever-growing understanding and curiosity. The names may change, and the classifications may evolve, but the wonder and pursuit of knowledge continue to spark our imagination and drive us to look deeper into the cosmos. Image 5. Stellar Snowflakes, the fascinating globular cluster NGC 6441. In the deep expanse of space, nestled within the Scorpius constellation, resides a cluster of stars known as NGC 6441. These stars come together in a display reminiscent of snowflakes, gently falling to Earth. But what makes these celestial snowflakes so captivating? How can we understand a globular cluster like NGC 6441 situated 13,000 light-years from the Milky Way's galactic center? Let's embark on a cosmic exploration to learn more. Imagine trying to count individual snowflakes in a snowstorm. The task would be almost impossible. Similarly, discerning the exact number of stars in NGC 6441 is a daunting task. These stars collectively weigh an astonishing 1.6 million times the mass of our Sun. This makes NGC 6441 one of our galaxy's most massive and luminous globular clusters. But how does such an enormous object form? What forces are at play to create this sparkling spectacle in the sky? Within the depths of NGC 6441 lies much more than just stars. 4 pulsars are found in this cluster, each completing a dizzying rotation in just a few milliseconds. A pulsar is a highly magnetized rotating compact star that emits electromagnetic radiation beams, like a cosmic lighthouse. Pulsars add to the complexity and intrigue of the cluster, and their rapid rotations inspire wonder. Also hidden within NGC 6441 is a fascinating object known as a planetary nebula. Now, don't be misled by the name planetary nebula. This term has little to do with planets. So what exactly is it? A planetary nebula is a phase in the life of intermediate mass stars. Think of it as a brief but brilliant moment in a star's life where its outer layers are cast off, leaving behind a colorful and glowing gas shell. This phase lasts only tens of thousands of years, a mere blink of an eye on astronomical timescales. However, why is it called a planetary nebula if it doesn't relate to planets? This peculiar name comes from early astronomers who thought the glowing objects looked like distant planets. There are around 150 known globular clusters in the Milky Way. These clusters contain some of the oldest stars in our galaxy, like cosmic elders telling tales of the universe's history. Yet, the details of their origins and evolution still puzzle astronomers. What secrets do these clusters hold about the formation of galaxies? How can we unravel the mysteries of objects so far away and densely packed with stars? NGC 6441 is an extraordinary example of a globular cluster with characteristics extending beyond its striking appearance. Located in the local universe and categorized as a part of star clusters, its proximity and nature offer tantalizing hints about the workings of the cosmos. The story of NGC 6441 is more than just a tale of stars grouped. It's a story filled with hidden treasures like pulsars and planetary nebulae, combined with the enigma of its origin and evolution. NGC 6441 is like a celestial puzzle waiting to be deciphered. As we continue to peer into the vast universe, clusters like NGC 6441 offer tantalizing glimpses into the complexities and wonders of the cosmos. What other secrets might such collections reveal? How does understanding them help us comprehend the grand narrative of the universe? In exploring NGC 6441, we're reminded of space's beauty, complexity, and intrigue. Like snowflakes, each star within this cluster contributes to a larger pattern, each with its unique place and role, coming together to form a captivating celestial spectacle. The wonder of the cosmos continues to beckon, inviting us to explore, question, and marvel at the stellar snowflakes that grace our night sky. Image 6. Central regions of 47 Tukanai. In the southern sky, amid the stars and the vast emptiness of space, lies an intriguing object known as 47 Tukanai, or NGC 104. It's a globular cluster situated in the constellation of Tukanai, also known as the Tukan. But what is a globular cluster, and what makes 47 Tukanai so fascinating? Let's dive into the celestial phenomenon to discover its unique characteristics and place within our universe. First and foremost, what is a globular cluster? In simple terms, it's a dense grouping of stars tightly bound together by gravity, all orbiting around a common center. Think of it as a bustling city of stars, where each star represents a building and the streets are invisible gravitational forces that keep everything together. 47 Tukanai is one such globular cluster, and it's far from us, located at a distance of 15,000 light-years from Earth. Situated in the Milky Way galaxy, this cluster falls under the category of star clusters. Thanks to the advanced technology of the James Webb Space Telescope, we can now peer into the central region of 47 Tukanai. This telescope enables us to study this cluster in great detail. But how exactly does it manage to capture such distant objects? The telescope uses a series of mirrors and sensors to capture light from faraway places like 47 Tukanai. It's like having a potent pair of binoculars to see into the distant cosmos. With this tool, scientists can observe and analyze the cluster's characteristics, enhancing our understanding of the universe. 47 Tukanai is more than just a collection of stars. It's a microcosm of celestial dynamics. The central region of this cluster, depicted in the image, is especially intriguing. Looking closely, you'll notice a dense concentration of stars at its core. The stars are so densely packed in this central region that they interact with one another, creating a crowded and chaotic environment. The phenomenon occurring at the heart of 47 Tukanai is known as core collapse. This is a process in which the gravitational interactions among stars cause them to migrate toward the cluster's center over time. Imagine a group on a dance floor. As they move and interact, some may gravitate toward the center, creating a denser and more lively area. Similarly, stars in the central region of 47 Tukanai migrate toward one another, resulting in a more densely populated core than its outer regions. Studying core collapse in globular clusters like 47 Tukanai provides valuable insights into stellar dynamics, evolution, and interactions. The stars in this region may undergo processes like binary star formation and mergers, adding to the intricate dance of celestial bodies within the cluster. As we gaze upon the central region of 47 Tukanai, we're reminded of the countless wonders of the universe. These distant objects offer insights into the mysteries of space and reflect the elegance of cosmic ballets that play out on a grand scale. What else lies hidden within 47 Tukanai? What secrets of stellar evolution and interactions will astronomers uncover as they continue to study this globular cluster? The central region of 47 Tukanai is a treasure trove of knowledge waiting to be unlocked by the curious minds of scientists and space enthusiasts alike. In exploring 47 Tukanai, we're venturing into the heart of a cosmic city, where stars interact, evolve, and reveal the intricate beauty of the universe. Each discovery gives us a deeper understanding of our place in the cosmos and a greater appreciation for the celestial wonders that grace our night skies. Image 7. Exploring 30 Doradas, a nursery of giants. In the intricate tapestry of the cosmos, the 30 Doradas region of the Large Magellanic Cloud, LMC, stands out as a remarkable sight of celestial wonder, known colloquially as 30 Dor or 30 Doradas. This region offers profound insights into the birth and life of some of the most massive stars. If our sun were a regular-sized car, some of the stars in this region would be as large as enormous cargo ships. These colossal stars challenge our understanding of stellar formation and growth. The 30 Doradas region isn't just remarkable for its size, it's also the largest and most active star-forming region in our galaxy. But how do we know that stars are forming here? Powerful telescopes allow scientists to observe intricate processes, witnessing gases swirling, gravitational forces at play, and newborn stars igniting. It's akin to watching a cosmic-scale slow-motion video of a flower blooming. The 30 Doradas region isn't merely a distant spot in space. It's a laboratory for understanding the universe. Astronomers grapple with questions about the conditions that allow massive stars to form, their impact on their surroundings, and their eventual fate. 30 Doradas serves as a reminder of the vastness and complexity of our universe. Its incredible star-forming activity and the immense size of the stars within it provide invaluable insights into stellar evolution and formation. It prompts us to continue exploring, learning, and appreciating the universe we inhabit. Image 8. Star Birth. The Tale of the Orion Nebula. In the cosmic dance of stars and galaxies, there exists a place where new stars are born, a place that humbles us with its complexity and grandeur. The Orion Nebula. Located in the constellation Orion, this nebula is not a hidden corner of the universe, but a prominent feature, 1,400 light-years away from Earth. What exactly is a nebula, and what makes the Orion Nebula stand out? A nebula is a colossal cloud of dust and gas in space, akin to a misty cloud hovering in the vastness. The gases in a nebula can be elements like hydrogen and helium, the building blocks of stars. Within the Orion Nebula, stars have formed from collapsing interstellar gas clouds within the last million years. The most massive clouds begin to collapse under their gravity, starting bright stars near the nebula's center. These stars are scorching, illuminating the remaining gas like streetlights on a foggy night. Fainter stars are still in the process of collapsing, glowing like embers in a fireplace. This turbulent star factory is a dynamic and complex region where stars are born. The Orion Nebula offers insights into the life cycle of stars, the conditions needed for star birth, and how different stars interact with each other and their surroundings. It is a place where we can witness the processes that have shaped our universe since its earliest days. The next time you gaze at the constellation Orion, ponder the intricate ballet of star birth, growth, and shine. The mysteries of space are not out of reach, but waiting for us to explore and understand. Image 9. Boulders escaping from asteroid Dimorphos, a collision experiment in space. In the deep void of space, a unique event took place that provided insight into the behavior of asteroids and the possibility of defending Earth from them. This event was the experimental collision with the asteroid Dimorphos. NASA's DART, Double Asteroid Redirection Test mission, aimed to answer a vital question. How can we protect our planet from a potential collision with a massive space rock? The concept was bold yet straightforward. Crash a half-ton DART impactor spacecraft into an asteroid and observe the outcome. The target was asteroid Dimorphos, and the mission's goal was to understand what it would take to alter its trajectory in space. The collision occurred nearly 4 months before an image of Dimorphos was born, revealing an astonishing outcome. The force of the crash had knocked off dozens of boulders from the asteroid, ranging in size from 1 meter to 6.7 meters across. These drifting boulders were not insignificant. They provided invaluable insights into the behavior of a small asteroid when struck by a projectile. Scientists could learn about the asteroid's composition and structure, how solid it was, and how it reacted to force. The collision with the asteroid Dimorphos was not just a dramatic event in space, but a scientific breakthrough that expanded our knowledge of asteroids and space exploration. It ignited curiosity about the mysteries of our solar system and reminded us that the universe is full of surprises. As you gaze at the night sky, consider the wonders it holds beyond the twinkling stars, asteroids, comets, and planets, each with its unique story and secrets. Asteroid Dimorphos and its drifting boulders remind us that we are still learning, exploring, and reaching into the unknown, striving to uncover the hidden layers of our universe. The universe is full of surprises, and we're just beginning to discover them. Image 10. Uranus. A dynamic world of mystery and change. Uranus, the 7th planet from the Sun, is a giant and remote solar system member, often overshadowed by its more famous neighbors like Saturn and Jupiter. However, Uranus's unique characteristics make it a subject of intense study and fascination. Situated in the constellation Orion, Uranus is a distant, cold planet that presents as a serene cosmic entity. Yet, its appearance is deceptive, for Uranus is a dynamic world of ongoing atmospheric changes and phenomena that challenge our understanding. One of the most intriguing features of Uranus is its thickened photochemical haze, which resembles Earth's smog. This haze raises questions about its origin and what it can teach us about the planet's atmosphere. Moreover, Webb's observations have detected several small storms near the edge of the polar haze boundary, adding to the complexity of Uranus's atmospheric dynamics. The North Pole of Uranus exhibits an interesting phenomenon. It grows brighter as the years pass. This phenomenon is not a mere change, but a complex interplay of factors that astronomers still strive to comprehend. The atmospheric circulation patterns on Uranus contribute to the changes in its polar cap, and scientists are eager to understand the processes behind this brightening effect. Uranus's seasons also play a role in these phenomena. During the Uranian equinox in 2007, neither pole was exceptionally bright. However, as the northern summer solstice approaches in 2028, the North Pole's cap may become even more brilliant. This alignment is even more exciting because the North Pole and the ring system will be directly aimed at Earth during this time. This alignment promises a clear and face-on view of the rings in the North Pole, offering opportunities for discoveries and revelations. Uranus is not just a remote, cold world in the depths of our solar system. It's a dynamic and ever-changing celestial body that challenges our understanding of planetary science. The James Webb Space Telescope continues to unveil its mysteries, reminding us that even the seemingly serene planets can harbor secrets waiting to be discovered. Image 11. Pillars of Creation, the Eagle Nebula Revisited. The Pillars of Creation in the Eagle Nebula hold a special place among the celestial wonders. Captured by the Hubble Space Telescope in 1995, this iconic image became an emblem of the cosmos, drawing awe and inspiration from people worldwide. The James Webb Space Telescope has revisited this celestial masterpiece, providing a fresh perspective on these towering columns of interstellar gas and dust. Located in the constellation Serpens, the Eagle Nebula is a vast region of gas and dust where stars are born. The Pillars of Creation are immense columns, several light years long, and incubators for new leads. Within these towering structures, gravitational forces squeeze and compress the gas and dust, eventually forming new stars. The Webb telescope's infrared vision pierces through the obscuring dust clouds, unveiling the intricate details hidden within the pillars. It reveals the glow of embryonic stars tucked away deep within the columns, their warm, radiant presence a testament to the ongoing process of stellar birth. One of the remarkable aspects of this image is the timelessness it represents. The light we see from the Pillars of Creation today left this region about 7,000 years ago. Since then, new stars have likely formed, and others may have met their end, altering the landscape of this cosmic nursery. The Pillars of Creation symbolize the universe's creative power, a visual reminder of the ceaseless cycle of birth and death that shapes the cosmos. They inspire us to contemplate the grandeur of the universe, the marvel of star formation, and the intricate processes that have led to our existence. As we gaze upon the Pillars of Creation through the eyes of the James Webb Space Telescope, we are reminded of the enduring beauty of the cosmos and the boundless mysteries that await our exploration. Image 12. The Cosmic Kaleidoscope, Galactic Collisions and the Birth of Stars. In the vastness of the cosmos, galaxies are the colossal structures that paint the universe's canvas. These island universes, each containing billions to trillions of stars, engage in cosmic dances that sometimes result in breathtaking collisions. Galactic collisions might seem like violent events, and in some sense they are. However, these interactions also create new stars, transforming galaxies and shaping the universe's tapestry. Webb's influential observations allow us to witness the intricate details of such cosmic encounters. One remarkable image captured by Webb portrays a galactic collision between NGC 6285 and NGC 6286, two galaxies located in the Draco constellation. Like many others in the universe, this collision has consequences that extend far beyond the collision site. Galactic collisions lead to the formation of new stars through a process known as starbursts. As the galaxies merge, the gravitational forces cause massive clouds of gas and dust to compress and collapse, giving birth to stars in spectacular fashion. These starbursts are like cosmic fireworks displays, illuminating the dark expanse of space with the brilliant light of newborn stars. They are also crucial to our understanding of galaxy evolution, as they can drastically change its appearance and characteristics. The intricate structures of NGC 6285 and NGC 6286, their swirling arms and luminous cores provide a glimpse into the complex processes during galactic collisions. The forces involved in these events are so powerful that they can alter the trajectories of stars, gas, and dust, reshaping the galaxies involved. Galactic collisions remind us that the universe is not static, unchanging. It is a dynamic, evolving system where celestial bodies interact, merge, and create anew. In these cosmic encounters, we witness both the beauty and violence of the cosmos and gain insights into the profound processes that have shaped the universe for billions of years. As we explore the images captured by the James Webb Space Telescope, we are invited to contemplate the grandeur of these galactic dances, the birth of stars, and the ever-changing nature of the cosmos. Each collision, like NGC 6285 and NGC 6286, tells a story of cosmic transformation that continues to unfold before our eyes. Image 13. The grandeur of Saturn. Rings, storms, and mysteries. Saturn, with its stunning rings and enigmatic storms, has captured the imagination of astronomers and the public alike for centuries. This gas giant, located in the outer reaches of our solar system, is a colossal world of beauty and mystery. One of the most iconic features of Saturn is its magnificent ring system. Composed of countless particles ranging in size from tiny grains to massive boulders, Saturn's rings create a breathtaking celestial spectacle. These rings are not static but dynamic and ever-changing, subject to the gravitational forces shaping their structure. The James Webb Space Telescope's observations of Saturn's rings provide valuable insights into their composition and behavior. Webb's infrared vision allows scientists to study the particles within the circles in unprecedented detail, shedding light on their origins and dynamics. Saturn's atmosphere is another source of fascination. The planet's distinctive cloud bands, composed of swirling gases, showcase a complex interplay of atmospheric phenomena. The Great White Spot, a massive storm that appears periodically on Saturn, is one of the most striking features of its atmosphere. Webb's observations enable scientists to study this storm and gain a deeper understanding of its nature and origin. Saturn's moon Titan, shrouded in a thick orange atmosphere, has also captured scientific interest. Webb's infrared capabilities provide a unique opportunity to study the moon's surface and atmosphere, unveiling the mysteries of this enigmatic world. The grandeur of Saturn, with its rings, storms, and moons, reminds us of the diversity and complexity of celestial bodies within our solar system. It encourages us to marvel at the intricate processes that govern planetary dynamics and contemplate the cosmos' beauty. Saturn is not just a distant gas giant. It is a celestial wonder that continues to captivate our imagination and drive scientific exploration. The images captured by the James Webb Space Telescope invite us to peer into the heart of this majestic planet, offering a glimpse of the mysteries that await our discovery. Image 14. The mysteries of Mars, Valles Marineris, and the search for life. Mars, the red planet, has long held a special place in human imagination and scientific inquiry. With its rusty surface and the promise of ancient rivers and lakes, Mars beckons us to explore its mysteries, especially in the search for extraterrestrial life. Valles Marineris, a vast canyon system on Mars, is one of the most prominent features of the Martian landscape. Stretching for over 4,000 kilometers, 2,500 miles, it dwarfs the Grand Canyon on Earth. This colossal canyon system is a testament to the dynamic geological processes that have shaped the planet. The James Webb Space Telescope has captured stunning images of Valles Marineris, revealing its intricate network of canyons, cliffs, and valleys in unprecedented detail. These observations offer insights into the geological history of Mars and the forces that carved this immense canyon system. But Valles Marineris is not just a geological marvel. It also has scientific significance in the search for life. The canyon's depths might harbor secrets of Mars' past, including the possibility of ancient water flows and subsurface aquifers that could provide suitable environments for microbial life. Webb's infrared observations also contribute to our understanding of Mars' modern climate and atmosphere. By studying the planet's weather patterns, dust storms, and atmospheric composition, scientists gain valuable information about the potential habitability of Mars and the prospects for future human exploration. Mars represents a frontier of human exploration and the search for life beyond Earth. The images captured by the James Webb Space Telescope remind us of the awe-inspiring landscapes of the red planet and the scientific questions that drive our missions to this intriguing world. Mars is not just a planet, it's a destination that fuels our curiosity and inspires our quest for knowledge. In wrap-up, the James Webb Space Telescope has embarked on a journey of cosmic discovery, providing us with breathtaking images and valuable scientific insights into the universe's wonders. Webb's observations invite us to contemplate the grandeur, beauty, and complexity of the cosmos, from the distant galaxies of the early universe to the mysteries of our solar system. These 14 images represent just a glimpse of what Webb has to offer. As the telescope continues its mission, we can look forward to even more astonishing discoveries and captivating images that will expand our understanding of the universe and our place within it. Webb's legacy will endure as a testament to human curiosity and the quest to explore the cosmos. I hope you liked the video. Don't forget to like, share, and subscribe to our channel. Thanks for watching.